cutie patootie, math angel. Welcome back. This is Decaf-math, ASMR. Today we are going to practice dividing polynomials using long division. So this is the more tedious but standard way of dividing polynomials. It's the most general way, so you can use this to work out whatever it is that you're looking at. So we are going to take our time step by step. So if you're the kind of person who's like, I'm done, then I just want you to know that ahead of time here. So feel free to just sit back, relax, zone in and out as you like. If you get sleepy, you can totally close your eyes and drift off to sleep, of course. And maybe you'll catch a tingle or two along the way as well. So I just hope that this blesses you however you like. I'm glad that you're here with me in our little math nook tonight or today. And let's just get right into it, okay? So we're going to take a look at 3 examples today, and as usual, I'll kind of chat about other types of questions you might see along the way. So for number 1, we are looking at x cubed plus 3x squared minus 11x plus 7. So that's our first polynomial. It has 4 terms which are separated by plus or minus. So that's our first polynomial, and we're going to divide this by x minus 1. And this polynomial has 2 terms separated by a minus. So we have a cubic polynomial here. The highest degree is a 3x cubed divided by a linear term here. X to the little secret 1. X to the 1 is x. So when we carry out long division for polynomials, the process is very similar to dividing with numbers. So we are going to start with our division like this. And maybe we'll do a side-by-side comparison for long division as well. So let's see here. Let's do, I'm trying to make up a question on the spot. How about 12 and 3, 4, 6, 8, 9, 6. I have no idea if this goes into it, but that's okay. So for this case, we have 3, 4, 6, 8, 9, 6 divided by 12. So the thing that is being divided by goes in here, divided by this. So we put this on the inside and this on the outside. So we're asking how many times does this go into this? How many times does 12 go into 3, 4, 6, 8, 9, 6? So I'll do x cubed plus 3x squared minus 11x plus 7. And then I'll put the x minus 1 out here. So let's go ahead and carry out this division. There are a few rules here for how to write this out, but we'll go into that after the problem. This one works out nicely. We lay it all out like this. And so when we do normal division, we take our 12 and we go one digit at a time. And so we say, does 12 go into 3? No, it doesn't, so we don't bother. Then we say, does 12 go into 34? Yes, it does. How many times, right? So normally we would go, how many times does 12 go into 34 without going too many? So if we do 2, for instance, 2 times 12 is 24. But if we do 3 times 12, that's 36, so that's too many. So we go ahead and write 2. So then we would do 2 times 12 is 24 and take it from there. And I do have a long division video, so I will reference that instead of trying to go into all of long division for arithmetic right now. But I just want to go into this pattern here because when we do this, it's pretty similar, but in a way it's actually simpler than that. So if we say x minus 1, how many times does that go into x cubed? That's a little tricky. So what we do is, because this has 2 terms in it, x minus 1, we have 2 terms, we're going to look at these 2 terms, x cubed plus 3x squared. And in this case, it's actually easier to determine what goes up here, because here you have to actually multiply it and check, but here all you have to do is compare x with x cubed. So you don't really have to bother with this part. You just compare x and x cubed, and when you do that, it's just x squared. So you do kind of have to remember your exponent rules, but it's just basically x squared times x, because 2 plus 1 is 3, gives you this first part. So you're only really comparing the first terms. So I have x squared when I compare x and x cubed, so I write that here. Okay, so I like to line things up like this, so when I have my answer up here, the squareds go here, the x's go here, and the constants go here, just to keep everything nice and lined up. So now when you multiply it out, you go x cubed, and then you have minus x squared, just like you would here. So once you determine your 2, you multiply it by 12, so you have 24. And so then you subtract and then put a line. So I'm going to do the same thing, subtract and put a line to see what comes here. So here you would have a 0 and a 1. For here, be careful, we're subtracting an entire polynomial, so we actually have parentheses here. So we do x cubed minus x cubed is 0, that's fine. And then we have 3x squared plus x squared, because you're distributing this negative. So we have 4x squared. Okay, and then what do we do for long division with numbers? We bring this 6 down like so. So I'm going to bring this minus 11x right there, right down. So 4x squared minus 11x, and then we carry on. So now for this, we want to know how many times does 12 go into 106 without going too many. So let's see, 9 times 12 is 108. So 8 would be just fine. So 8 times 12 would be 96. So 96. Bring it down, subtract, borrow, 10, 10. So for here, all we have to do to know what the next term is to compare x and 4x squared. So instead of having to really care about this second digit here, all we have to do is compare these first terms. So how many times does x go into 4x squared? Well, that would be 4x times, because 4x times x is 4x squared. It's x to the 1 plus 1, and then the 4 just stays as a coefficient. So we have plus 4x. So then we multiply like this, and so we get 4x squared. And then we have minus 4x. So if I were to do 4x times x minus 1 in parentheses, we're basically doing the distributive property. Get the idea? So then you continue and bring the 8 down here, like so, and carry on. So for here, we do the same thing. Subtract, put the parentheses around this. So we have 4x squared minus 4x. That goes away. That's fine, as expected, because we chose the 4x to do that. And then we have negative 11x minus minus, so that's plus 4x. So that would be negative 7x. And then bring down this plus 7. And so then for the last term, we compare x with negative 7x, and that would just be minus 7. So that we have minus 7x, negative 7 times negative 1 is plus 7. And then we subtract, and that's 0. Perfect. So we have no remainder in this one. I guess we can't just leave this one hanging here. We can finish it off. How many times does 12 go into 108? Well, we have 9. So 108. So that's 0, which is fine. A little strange, but fine. Then we have 9, and that would be 0 times. So this would just be 0, and then 96. Wow, actually, that worked out perfectly. Well, what do you know? I actually really just made up these numbers. There's a little bit of intuition involved in that, 2 and 6, like if this is going to go in evenly, this would have to be even. But aside from that, I kind of just made up some digits. But what do you know? The remainder actually is 0. That's really nice. So we have 0 for our remainders, which just means that this goes into this evenly. So our answer would be x squared plus 4x minus 7 for this first question. Very nice. Okay, so this divided by this is x squared plus 4x minus 7. The nice thing about division is you can always check by multiplying things back out. So this times x minus 1 should give you this if you were to expand everything out. And remember, when you multiply polynomials, you want to multiply every pair of terms, keeping in mind you have addition, well, plus or minus. And so when you multiply a positive with a negative, you'll get a negative. And then when you combine like terms, you should get a simplified answer. And in this case, you should get this x cubed plus 3x squared minus 11x plus 7. Okay, perfect. And so if we have no remainder, that's fine. That's just our answer. And all is good. All is well. So the key little rule that I want to emphasize here is, I feel like as long as you kind of remember this pattern for long division with numbers, this might help you remember what's going on here. The key differences are simply that you only really need to compare the first terms, and then you carry out the distributive property for the rest. And then the other key thing is, when you subtract, you want to subtract the entire bit that you multiplied out, meaning you distribute don't just subtract x cubed and then do this. You have to do 3x squared plus x squared, or minus if this is a plus. So you do have to distribute that negative when you do the subtraction step. And then the other kind of little tip here is that when you actually write this out, in this case we didn't have to worry about it because the exponents worked out nicely, but when you write out each of these terms, you want to make sure that the degrees or the exponents are decreasing or consecutively decreasing. So here we have x cubed as the highest power, but then we go from 3 to 2 for the power of our x, so x cubed to x squared. The x or the coefficient is fine, the number in front is fine, but we go from 3 to 2 to 1. The x is x to the 1, and then our constant, which is really like a secret, x to the 0, because x to the 0 is 1. So we want to go 3, 2, 1, 0, consecutive, decreasing consecutively, if that makes sense. So if we have a power of 5, we want to go x to the 5th term, and then x to the 4th, x cubed, x squared, x, and then a constant. And if you happen to have a polynomial that skips a term, like if, let's say, this 3x squared didn't exist, we just have x cubed minus 11x plus 7, that's okay. You just put in a plus 0x squared or minus 0x squared, but usually just go ahead and do plus 0x squared as a placeholder. And that's really the standard form for polynomials. So you just start with your largest degree ascending by 1 and just put in a plus 0 whatever term is missing if there is one. Okay, and that's about it. That's the only kind of key thing to remember here, and it's just all about having fun from there. So let's try another one. Let's do 2x to the 5th minus 3x to the 4th minus 8x cubed plus 22x squared minus 17x plus a 3. So this huge polynomial divided by 2x minus 3. So I'm going to work this one out slightly faster. Don't worry about a thing. There's no need to stress. I'll do all of the work. You can try along too, or you can pause this video right now if you are reviewing this and try it yourself, and we can compare answers. You can let me know if you get the same thing that I do. But I just want to show you that once you get into the groove of it, it doesn't have to take a really long time or anything. So, division sign, nice. I'm going to put this thing underneath here. I notice that I have x to the 5th, 4th, 3rd, squared, linear, constant. So we don't have to worry about putting in any zeros. So just 2x to the 5th minus 3x to the 4th minus 8x cubed plus 22x squared minus 17x plus 3. Excellent. And then we have 2x minus 3. Also, just as a little heads up, our examples here have binomials, but if you have more terms, it's the same idea. Just make sure that if you have a higher power here, again, make sure that it's written with decreasing exponents in order as well. So put in your 0x or 0x squared if you need it for placeholders. That way, when you distribute, when you multiply things out, it's all nicely lined up here again. Okay, but the same pattern, same rules apply. So let's give this a go. I see that I have compare those, and I just need to multiply by x to the fourth. So I'm going to line it up here. Not everyone lines it up this way, but I like to, just to make sure everything stays neat and lined up. So 2x times x to the fourth is 2x to the fifth, and then I have a minus 3x to the fourth. So then I subtract like so, and I'm distributing the minus sign. So this is 0, and this is actually 0. So I do minus 8x cubed. I bring this down. This is a little strange, right? Because I go 2x into negative 8x cubed. So because this was 0, it actually skips the cubic term. So I can put a 0x cubed here if I want to, if that helps. Or I can just go ahead and move on and bring this down. I'm going to go ahead and write 0x cubed just to keep this consistent first. So 0x cubed. So this would be 0 minus 0. And when I write my final answer, this goes away. Because you don't need to keep a 0, right? So then I bring that down, everything is 0, that's fine. So negative 8x cubed. And now I bring down the 22x squared. So now I'm comparing 2x with negative 8x cubed. So that would be negative 4, because 2 times negative 4 is negative 8. And x squared, because x times x squared is x cubed. So negative 4x squared. So you just do the constant parts first, and then you can do your exponent rules to divide this out. And so we get negative 8x cubed, then negative 4x squared times negative 3. So negative 4 times negative 3 is positive 12, and then I have an x squared, so plus 12x squared. Subtract, bring down, distribute this negative. So I never bothered to do this first term, because if we did this correctly, the whole point was to get rid of this. So we're always expecting this first part to be 0. So it's really just figuring out what this remainder is. So 22x squared minus 12x squared is 10x squared, down the negative 17x. So 2x into 10x squared is plus 5x. So we have 10x squared. 5x times negative 3 is negative 15x. Subtract. Very nice. Negative 17x. Again, don't bother with the first one. We have negative 17x plus 15x. So that's negative 2x. And bring down the 3. So plus 3. And so then 2x into negative 2x is negative 1. So then negative 2x plus 3, which leaves us with no remainder. Very good. So this term goes away. Our final answer would be x to the fourth minus 4x squared plus 5x minus 1. And again, if you want to actually check that by hand, you take this thing, multiply it by 2x minus 3, multiply all pairs of terms here. This times this, 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 this times this. Combine the like terms and you should hopefully get this. Let me know if you get anything different, okay? But point being, as long as you keep things in order, you should be good to go. If you want to kind of just skip over this 0 part, that's totally fine, but just make sure that you don't lose a term here, because this is a binomial, so no matter what you multiply, you're going to get problem if you just have one term here, because you'll kind of be off by one as far as the places go. So that was my kind of point for this question. Okay, so let's do a third one, and let's go ahead and try an example where we have to put in a 0. So here we have 3 terms divided by 2 terms. X cubed minus 12x plus 7. That's a polynomial divided by x plus 4. So when we write this out, like we said, we have to fill in, there's my division, we have to fill in any missing degrees. So we do x cubed, and then I don't have an x squared, so I'm going to put in 0x squared, and then minus 12x plus 7, and then x plus 4. Okay, and so here we have a linear and a constant, so that's fine. And now we just carry it out as usual. So I'm comparing x to x cubed, so that would be x squared. So I'm going to line it up with this x squared place. X squared times x is x cubed. X squared plus, or multiplied by plus 4, so that's 4x squared. Subtract, put parentheses. This part goes away. I have x squared, or 0x squared, minus 4x squared. So that's negative 4x squared. Bring this down, negative 12x. So I compare x with negative 4x squared. So that's minus 4x. So negative 4x times x is negative 4x squared. 4 times negative 4x is negative 16x. Negative 4 times positive 4 is negative 16. The x is there as well. Subtract with parentheses. Negative 12x plus 16x is positive 4x. Bring the plus 7 down. And x goes into 4x 4 times. So plus 4. 4 times. So 4 times x is 4x. 4 times 4 is plus 16. When I subtract this, I get 7 minus 16, which is negative 9. So in this case, we have a remainder. It's not just 0. That is perfectly okay. Just like when we do division, sometimes we have a remainder, right? And so either you can turn that into a fraction, or you just write remaining whatever, right? Like if I were to do 421 divided by 3. So I would get 1. So I would have remaining 1. So you'd either do 140 remaining 1, or 1 over 3 as a fraction. So here, normally we wouldn't write remaining negative 9. That's a little weird. So normally what you would do is take this remainder, whatever it is, and put it over this. Because when you multiply this out, you distribute it back, you're going to get the negative 9 to give you the constant part. So here you just take your remainder, put it over this. In this case, you take your remainder and you put it over this. So usually that's what you would do if you have one. As long as you take it all the way down to your constant term, because again, you should be filling in zeros, so you should have at least a placeholder for the constant term. You bring this down, and as long as you take it all the way down to this, your remainder should always have a lower degree, a lower power this though, because otherwise this would be able to go in more. So if you had like an x cubed plus 0x squared plus whatever, this should have less than a power of 3, but your remainder might be, x plus 4 or something like that. Because then when you're comparing the x cubed with the x, you can't go in a whole number of times anymore. So you just stop there and you write, x plus 4 over x cubed plus whatever else. So here we go. This would be our answer, x squared minus 4x plus 4 minus 9 over x plus 4. Hopefully our calculations look okay. If you are actually working on this for review or practice, I hope then you got the same answer. Let me know if not. But again, you can just multiply this out if you are into checking your work. Otherwise, we will just take it as it is. I hope that this was helpful and a nice little relaxing review. If you are asleep right now, I'm wishing you a sweet mathy dream.